Welcome to this explainer. I am so glad you're joining me today. We are going to look right past the surface of the things we see every single day and uncover the invisible forces driving them. We're talking about the hidden acid-base chemistry that powers some highly visible, very dramatic, and honestly, incredibly colorful everyday phenomena. We're going to break down the science, and more importantly, we're going to show you how to apply it in some really fun, hands-on, practical ways.
So let's dive right into this with a bit of a curveball question. What do a science fair volcano, a painful wasp sting, and a beautiful blue flower all have in common? I mean, on the surface, absolutely nothing, right? One is a childhood rite of passage, one completely ruins a summer picnic, and the other is just a nice addition to a garden. But beneath the surface, they are all governed by the exact same chemical principles. It's that delicate and sometimes really volatile dance between acids and bases.
Let's start with a foundational example. Section 1. The classic kitchen volcano.
Now, what's really fascinating about this classic eruption is the exact precision behind all that bubbling chaos. To get the absolute best reaction, you can't just casually dump ingredients together and hope for the best. According to the data, the magic fraction for the base of your eruption is exactly 1/4 of a cup. That's 1/4 of a cup of baking soda, scientifically known as sodium bicarbonate, and that is going to act as our base.
And to complete this golden ratio, you need exactly 1/2. That's 1/2 cup of vinegar, which contains acetic acid. When you combine that solid base of sodium bicarbonate with the liquid acetic acid, boom, you trigger a rapid, incredibly visual chemical reaction.
All right, let's see how this builds into some practical work. If you want to safely create this massive, foamy, carbon dioxide-producing eruption right at home, here is the structured breakdown. Step 1. Build a volcano shape around a central container using clay or paper mache, whatever you have. Step 2. Drop in your 1/4 cup of baking soda. Step 3. Pour in your 1/2 cup of vinegar. But wait, here is an awesome pro tip from our sources. If you mix a little dish soap and some red food coloring into the vinegar before you pour it in, well, the carbon dioxide gas produced by the acid-base reaction gets trapped inside the soap. This creates a massive, thick, super realistic lava foam that bubbles right over the top. It is a perfect, highly visible demonstration of rapid gas expansion caused by an acid neutralizing a base. And that brings us right to Section 2, neutralizing wasp stings. You know, when a wasp stings you, it isn't just poking you with a tiny needle. It is actively inserting an alkaline solution, a base, directly into your skin. This alkaline venom is exactly what causes that severe, burning pain and intense irritation. But because we know how acid-base chemistry works, we know exactly how to fight back. You counteract a base with an acid. By applying a weak acid, like literally that exact same vinegar we just used in our volcano, directly to the wound, the acid goes to work neutralizing the alkaline venom. The chemistry happens right there on your skin, soothing the pain and calming down the irritation. It's like a real-life chemical shield.
Okay, Section 3, nature's colorful pH indicators. This is where the chemistry gets intensely visual.
To really understand this, we have to look at a very specific botanical mechanism, anthocyanins. These are water-soluble flavonoid pigments that accumulate inside the vacuoles of plant cells. And here is their absolute superpower. Their molecular structure is unstable. That means they physically change their shape, and because they change shape, they change the color of the light they reflect based entirely on the environmental acidity around them. They are literally living, naturally occurring pH indicators.
The most famous poster child for this is the humble red cabbage. Actually, before we look at its scientific magic, let's just briefly appreciate its incredible nutritional profile for a second. This vegetable is 91% water, packed with 44% of your daily vitamin C, 72% of your vitamin K, and it is rich in phytochemicals like sulforaphane. So yeah, it's a total nutritional powerhouse. But for our purposes today, its most important feature is that it is a natural, entirely edible pH indicator, absolutely loaded with those shape-shifting anthocyanins we just talked about. And the way this works in practice is stunning. If you extract the juice from a red cabbage, it creates this incredible colorful spectrum depending on what you mix it with. If you expose that cabbage extract to an acidic environment, so a pH less than 7, think lemon juice or our trusty vinegar, it instantly turns vibrant red, magenta, or pink. In a neutral state, hovering right around a pH of 7, it stays purple. But if you expose it to a basic or alkaline environment, a pH greater than 7, like baking soda or ammonia, it shifts completely to blue, green, or even yellow. The plant literally changes its physical color to tell you the chemistry of its environment. How cool is that?
Which brings us to Section 4, the hydrangea color mystery.
Just look at the beautiful gradient we have here. On the left side, we have these deep blue flowers, and those correspond to the highly acidic side of the scale, from a pH of about 4.5 to 5.5. As we move across the gradient to the right, into the more basic, alkaline soil between a pH of 6 and 7, the flowers transform to this vibrant pink. It's an incredible, naturally occurring, colorful diagram right in the dirt. But what's really fascinating here is that the pH itself isn't actually what's turning the flower blue. The pH is just the key that unlocks a much more complex chemical reaction.
So the absolutely crucial point is this formula right here. Acidic soil plus available aluminum equals blue hydrangeas. You see, aluminum is a heavy metal that's naturally found in a lot of soil, but in neutral or basic soil, that aluminum is locked up tight. The plant can't absorb it at all. However, when the soil becomes acidic, it frees up those aluminum ions. The hydrangea roots absorb this toxic heavy metal, and when that aluminum interacts with the anthocyanin pigment up in the flower's petals, it forms a complex that turns the blossom a rich, beautiful blue. No aluminum? The flower stays pink, even if the soil is super acidic.
Now, I know what you're probably wondering. Wait, isn't aluminum toxic to plants? Yes, it absolutely is. And that's exactly what makes the hydrangea an absolute marvel of biology. They belong to a special category of plants known as hyperaccumulators. These are plants that can safely accumulate incredibly high quantities of heavy metals inside their tissues without dying. Hydrangeas can absorb up to 5 milligrams of toxic aluminum per gram of dry leaf weight. They pull this off through a clever internal detoxification process, storing the metal safely away in their vacuoles where it won't damage the cell. They literally eat toxic metal and turn it into art. All right, time to get our hands dirty. Section 5, DIY soil testing.
Let's walk through the exact step-by-step process of creating a homemade soil testing kit using items you probably already have sitting in your kitchen right now. Step 1. Take a spoonful of soil from your plant pots or your garden and mix it in a container with some distilled water. Give it a good stir and let it settle. Step 2. Dip a piece of white filter paper, or even just a clean white cloth, right into the water-soil mixture. Step 3. Expose that wet paper to your natural indicator. You can absolutely use the juice from that red cabbage we were discussing earlier. Step 4. Observe the magic. If the cabbage juice on the paper turns pink or reddish, your soil is acidic. If it turns bluish-green, your soil is basic.
And hey, if you don't happen to have a red cabbage lying around the fridge, here is a brilliant alternative: turmeric paste. Turmeric acts as a fantastic natural indicator too. Just expose your soil water paper to a little turmeric. If the turmeric stays its natural yellow color, your soil is either acidic or neutral. But if that turmeric turns a deep, dark, reddish brown, you have basic alkaline soil on your hands. It is an incredibly fast, highly visual, and entirely natural way to decode the hidden chemistry of the ground right beneath your feet. You see, chemistry isn't just something that happens in some sterile laboratory with complex equations on a whiteboard. It is bubbling up in your kitchen sink. It's the secret weapon for soothing a nasty bug sting. And it is the invisible artist painting the petals of the flowers in your own backyard. So I want to leave you with this provocative thought to chew on today. Grab some cabbage, maybe a little turmeric, head outside, and find out for yourself. What color is your garden's chemistry? Thank you so much for joining me on this explainer. Keep questioning, keep experimenting, and I'll see you next time.